Right, my name is Oliver Sturm. I work with this company called DevExpress. This is all not very important stuff. I have a lot of background in creating software, and I've always been interested in architecture. So that brought me to event sourcing and CQRS and event sourcing systems years ago. And I have always loved that architecture ever since I started using it. Now, at DevExpress, and I'm not telling you this to sell you anything, but to kind of talk about the background here, we have created this system called Resolve, which is a JavaScript-based CQRS event sourcing framework for developers. And we have been dog fooding this a lot, and we have run a couple of projects with it, and I have run some other projects with event sourcing systems. I have done some workshops on creating event sourcing systems, and from that background, I am here to talk about the process of updating a system to its next version. So that's where I'm going to begin with the consideration of what a version actually is. What can that mean? Obviously, there are different interpretations of that term. So that's where I would like to really get started and think about what does it mean? What happens when we have basically made a development step and then we have completed something? We would like to make that available, presumably. But the question is, which elements does it entail? And that's the first thing I'm going to look into. Then after that, we have simple changes and more complicated changes, right? Basically, adding and removing individual architectural elements from our application system. More complicated scenarios where there are changes to particular bits. Foundation, what is it when it's not my code that changes, right? I'm meaning to actually point at those bullets as I go along as well. So what if the underlying framework changes, or I would like to migrate the system to an entirely different platform or a different database or something along these lines. And then the final one of those bullets on here is about the biggest kind of update, if you will, which is basically very similar, which is the first step you ever take in the direction of an event sourcing based application system. That is, if you begin with some kind of a legacy system, let's call it that does not use event sourcing, and now you would like to migrate to a new application architecture that does use event sourcing. That's like a very large update step, if you will. And I'm going to be talking about that as my last point, hopefully, if I'm okay with time and everything. Right, so that's the idea for today. Now let's see what an update is, first of all. We have all, I suppose, created applications, and the biggest problem really with updates in general is that it's one of those topics that is easily forgotten in the beginning, isn't it? You start creating your application, and at some point you deploy it, and then you might have a couple bug fixes maybe at some point, so that's important. But you also have further plans. So the general idea of what is an update, of course, means that you have completed some extra step that you wanted to make. But in reality, there are many different details that can change about a system, and I've listed some of them here, maybe not all of them. You might have, depending on your system, and maybe have some other ideas, I don't know. But I guess some of the thought processes are similar. So we can basically add or remove read models to our system. We can add or remove events. I'm going to go into the details of most of those scenarios in a moment, just so you know. Yeah? So this is only a summary at this point in time. We can add, remove events. These are basically the simplest ones. I'm beginning from the simple side of it. We can have changes to an existing thing, like a read model, for example, that can be either fixed for bug reasons or changed as a matter of evolution, or it can be extended. That's a slightly separate topic that I'm going to address. We can also replace a read model with a completely new implementation. And then what to do when you think events should change. I'm putting it carefully like that for a reason. We'll get to that. And again, the technical level of the application system. So basically what happens if something in your underlying technology stack changes, for example. And then the final note here, an update again could also be the actual first step towards an event sourcing system. And so these are different types of updates that I have identified. I can imagine that somebody could maybe go into more detail and distinguish these individual blocks even further. So that's not meant to be the very last word on that topic, but these are the ones that I think are relevant here. Now, whenever we update anything, of course, the main goal is to be able to run the new version of the application, right? That's clear, with whatever new functionality we have implemented or bugs we have fixed or any of that sort of stuff. However, there are some equally important or almost equally important side goals, and one of them is to prevent downtime, and especially that is important on the right side. Now, I'm putting this here as the first bullet because I think that in many application systems, this is the slightly more important priority to prevent downtime on the right side. Prevent downtime on the read side is obviously the next bullet down. So if, depending on your system, you think that the read side is perhaps more important than you could think about that, you could change the priority there. I do believe that it's somewhat important for your update processes, for how you outline your strategies and what you do to consider fallback scenarios right here. To make good decisions about these details, it can be important to have those priorities sorted out, right? So this depends on your application system's usage patterns, on what happens internally. Is it more important to you that people can always access the read side of your application, or is it more important that commands will always be accepted and handled, perhaps even in a timely manner, and so on? These are priorities that you might have to sort out ahead of time. So that's my heads up in that regard. Right. So to get into some of those update scenarios, I've begun with a simple one. When it's simple, I try to use some visual diagrams just to illustrate things a bit and make the text on the slides less boring. So this is a simple diagram that indicates how things can change when a read model is added or removed. Now, this is basically a pretty simple process that you might have, of course, performed yourself before. So the idea is that, of course, in any given system, event sourcing system that is, I should be able to create and add a new read model to my existing architecture without too much hassle, right? That's the green arrow down here. And the green new RM5 read model, right? Creatively named that. I had to come up with something. So the new read model should be populated directly from the event store by simply replaying your events into that read model. And then you should be able to build it from there. Since it hasn't been there previously, presumably this should not have any direct influence on anything else that's happening at that point in time. If you will have, this is actually a line that is not in this particular diagram here. We have a client up here, right? So if you have some kind of a client that would obviously try to access the read model for data, then it's a good idea to have the read model built completely before you actually allow the client to begin making those requests. However, there's also the consideration that this client could, in the other case where we remove a read model, try to still access that read model that is not there anymore, right? So these are all kind of simple beginning scenarios, of course, and yet there are already some considerations. So from that point of view, it makes a lot of sense to create all your client code in such a way that they anticipate a read model potentially not being available for a while. Now, you say, well, of course we do that, right? We handle exceptions or whatever it is in your programming language and environment of choice. So I agree, yes, of course you will be doing that. But the question is, how exactly do you do that, right? So for example, if this client is a front-end application with an end user basically in charge of, the browser or something that they do, then how should that front-end application react in the case that a read model cannot be found? Now, if you think about your deployment, your runtime handling of situations like that, then the only thing that probably comes to mind is that if a read model is not available, then that's an error situation that should hopefully pass soon, right? That's fair enough. But as we can see, this is an error situation that can also arise depending on your particular update strategy, the order in which you deploy updates to the read models and to the clients and so on. You take down this this read model down here at some point, right? It might just be not available anymore, ever, at some stage. Then the question becomes, how do you handle these scenarios? And I recommend creating your client code in such a way that it is tolerant of issues like that. Consider this right from the start, that this might happen at some future point in time, because it makes your update process that will come around at some point in the future a little more stable, a little more graceful from an end user's perspective, for example. Right, so that's a simple case to begin with. And another simple case is adding an event or command and an event, right? So adding, of course, is technically very easy. You begin by, you update your, command interface, command processor component of your system to handle the command, project, aggregate, store, publish events as they always do. And as long as, let's say, there is no read model in your system that cares about the new command or event coming through, nothing happened. Okay, so that's not a problem at all. Now, of course, the idea is that we would probably introduce a read model into the system, or perhaps apply a change to an existing one to actually handle this new event that is now part of the system. And in that case, it might make sense to consider updating your read model first. That's an idea. I'm not saying it's necessarily the best recommendation, because it can be somewhat complicated in a larger system to try to influence your update order like that. The alternative, of course, is to rebuild read models after you have added the support for this new event. So you replay your events and rebuild on that basis a little later. And in any case, adding an event is still a very, very simple kind of operation to perform. Right, so what about removing an event? Now that's, that kind of fits in at this point, because I had, add, remove a read model. Now we have add and potentially remove an event. But this is something that I'm only mentioning really because it's a, maybe from the perspective of people who are not very, very experienced with event sourcing, they have ideas like that. What if I don't want this event anymore, right? So I suspect that you have probably read most of my slide by now. Of course, do not modify what's in your event store just because somebody says, we don't want this event anymore, it's not needed in the future, that kind of thing. I would not recommend ever dropping the event from the event store, or at least I'm not even going into this, but technically, of course, this would be a much more complicated reconsolidation sort of operation, perhaps. Don't even want to talk about that. So removing an event basically just means that you will stop generating it, right? So you will not accept the command anymore that might generate this event. And in case you have incremental import interfaces in your application, which I'm going to get back to a bit later as well, stop accepting the event through any such interfaces, right? So it's as if it doesn't exist anymore, basically. However, because the event presumably has become part of your event store at some point, any read models that were originally handling this particular event should also process it as before. You cannot remove that logic from the read model There is usually, the best recommendation is not to do that ever. There are probably exceptions, but that's a bit out there really. So the best recommendation for general practice is just to not do it. Technically, no other extra steps are required, right? If your event is just basically not generated anymore, then that solves the entire update problem quickly. Now, if an event model changes or needs to be fixed, which is technically more or less the same kind of thing, then of course the answer is to rebuild it. That's what is, perhaps hopefully indicated by this entire scenario down here. We have this hypothetical old storage of the event model, the read model, that contains some bits that require replacing. And then we basically replay the events from the event store, right, like before, and we create a new storage. Right? And of course, eventually we could also drop or completely throw away the old storage. So that's the idea. Now, the question of whether you are actually fixing or changing your read model can still be an interesting consideration, because there's a decision to be made, and that decision is, how will you handle incoming queries during the rebuild process, right? Now, I can't really answer that question for you because it depends on the scenario. It depends on what is wrong, and it depends on what that read model, what the role of that read model is in your overall application context. So if you have a fix to apply, that means that something is wrong, there is invalid content in your read model storage perhaps, and therefore query results are logically nonsensical, right? Then I suppose it makes a lot of sense to simply take the read model offline. But it's up to you to assess the damage or the potential damage of whatever incorrect information is coming out of that read model. On the other hand, if you're basically applying a change, an evolutionary change to the read model, then perhaps it's the best idea to actually keep answering queries from the old storage as long as the new storage has not been fully populated yet. And then basically start using the new storage when it is complete. Right? So that is up to you. And for that reason, though, this slide is titled Fix or Change, because depending on this particular consideration, you have to make that decision. I'm just, checking my notes to see. All right, good. Okay, now a somewhat frequently asked question in this regard is it possible to also just extend a read model? Or, I mean, the just is important in that context, in quotes, as it is in the title of the slide here. Can I not just extend it? So in other words, maybe I have the idea that I could do some extra calculations on the basis of data from some event that is coming in, right? So I could add some handling or projection logic, as it says up here. But then I could also live with the idea that not all the data persisted by the read model actually contains this additional calculation result, right? So maybe I'm not going to rebuild the read model, because technically it's like, a costly effort to do this, and it's a time-consuming process to do this. And maybe I'm altogether better off by just adding the extra logic and not rebuilding, so that some of my data will then contain the newly calculated information and the other will not. Now, I don't really believe that that's a good idea, right? People come up with all kinds of reasons, as you can see here, why this seems like a good idea to them. I do not believe that that's a great idea. I would not recommend doing it. I suppose that, technically it can be a little difficult to argue against it when people bring up this idea. But to me personally, I would always think that the consistency of the data in your read model is more important than anything else. And of course, it is actually one of the advantages we have as a result of using an event sourcing based architecture to begin with, that we can comparatively easily decide to rebuild event models when that becomes necessary. So I would always recommend to do it, and therefore keep your read models consistent at all times. Again, a question that comes up somewhat frequently in discussion with people who haven't used event sourcing, or not for very long at least, because that seems to be an obvious idea, I suppose, from the perspective of a more legacy sort of relational database storage mechanism or that sort of thing. Right. A read model, of course, can be completely replaced, right? So that's quite obvious, because we plan on doing that, from, I don't know, if you're into microservices architectures or that kind of thing, right? The idea is always that if my read model will one day be running much more efficiently with technology X instead of Y, or on a new platform, a completely different technical implementation, right? That's the idea. If we find ourselves wanting to create a new version of the read model, then of course we can go ahead and do this. And the new read model presumably then answers all the same queries, at least, once we've built it. That's the idea. It should work the same as the old one. I mean, maybe it's going to be, better over time. That's perhaps the idea with rebuilding it in the first place. But in order to replace the existing one, we should be able to assume that the queries are all answered in the same way. So that means I can therefore bring this read model up in parallel, build it, and then at some point switch to it. So this would be one way of doing it. Alternatively, I can actually run the second read or a second read model in parallel to the original one, perhaps temporarily. The difference, I don't know if my words on the slide are actually perfect here. The difference that I intend to convey here is mainly the one that it depends on where the switch happens, right? So on the one hand, let's say I'm using some sort of a message passing system in my architecture, and I've got this message that triggers the read model, or maybe a query endpoint or something like that. Then on the one hand, the read model itself can decide to suddenly take over for read model A, right? Read model B says, all right, I'm going to answer all those queries now. Or alternatively, I can basically implement read model B using its own verbs, its own endpoints, whichever exact access method you use. And then I will be able to run clients in parallel, that some of which use the old approach, some of which use the new approach or read model, right? Potentially that allows me to switch back to the original situation if my new implementation randomly ends up showing issues, for instance. So that's why I'm saying down here that this approach here is meant to result in a more stable situations, right? So the clients would not have to all upgrade to work with the new read model on the spur of the moment. They would not have to expect anything to work differently. They could just be routed to the new read model selectively, which runs in parallel with the existing one. Temporarily, presumably, so at some point we're going to switch it off. But the important idea about this approach is that there is no particular time limit on that idea. We could theoretically leave it running for quite a long time, or even go back to the original one if it turns out to be, a bad new implementation for some reason. Then again, for the parallelity here, we've got the idea of also fixing, changing, or extending events. And one more time, as I've said before, of course, the idea is never to actually modify existing events in any way. Right? That's kind of important to stress. I don't know. I guess most people here might think, yeah, that's obvious. We don't do that anyway. I certainly hope you do. I regard the event store as a completely immutable entity, and I recommend you do that as well. But it can just not be stressed enough, I think. Sometimes you might find yourself having to actually rebuild your event store. This is obviously something that doesn't really happen very often, but it can happen usually for certain technical reasons, maybe technical issues that you have discovered, or when you migrate to a different storage technology, that kind of thing. You're now running a different database type for your event store, or perhaps you've actually running in a completely different cloud architecture, or whatever else might influence things on a technical level. In that case, you might have to rebuild your event store. And this is easy enough to do technically. I recommend replaying events from your old event store and building the new one on top of that, or from that information, basically. Very similar to the way you would do it for a read model, right? So the event store, the new event store, would basically act as a read model in this pattern and build up its own understanding of the events that have come in. I would not recommend ever changing the event payloads in the process, by the way. That's never a really good idea. You can, however, transform structure of other elements of the persisted events, if that is necessary. Maybe the new database platform requires a different structure for timestamp information or any of that sort of stuff. And another thing that's important to remember whenever you recreate your read model is if you have any extra information that is relevant to the command processing and event store process, it is important to replicate this at this point as well. I mentioned here as an example secrets. This is something from experience in our own framework. We have this mechanism for secrets which can be stored on that level, basically separate from the event store, and it allows the event store to encode events, encrypt them for security, and to provide a crypto shredding ability when data has to be dropped for any reason or that sort of thing. So this is one example, right, of information that is parallel. There might be some other types of information that is parallel, like, for example, external storage, like data that is stored in a cloud storage service, like an S3 thing or something like that. It's just not normally necessary to do much about. If you have a resource in S3, for example, then you would basically have a URL that is a part of some event data, perhaps, and that's in the payload, right? So we wouldn't touch it, but it's definitely a good idea to consider whenever you try to rebuild your event store, if there is anything else that is relevant to your particular application system at that point. For everything else, it says here, use either new events or versions, right? There is a book that Greg Young is writing, ES versioning. I recommend having a look at that if you've not seen it so far. It basically goes into some detail on the idea of having events, and then how and when to create a new event that might either be a new version of an existing event or perhaps an entirely new type of event. So these are distinctions that Greg Young makes in this book, and I recommend giving that a look for everything that has to do with the evolution of events themselves. This is in itself a pretty complicated topic, but I mean, generally speaking, these are the recommendations, right? Create new events whenever you find that the event actually does something ever so slightly different from the old one, then it makes sense to have a new one. And if you find that you just would like to introduce another extra field or something into the event, then you can use a version. That's the general best practice. I think in this book I saw that Greg Young describes it as saying, if you imagine your event being implemented as a type, then it should be possible to basically upcast it. In other words, so basically if the new event has a couple extra fields, and it's perfectly easy to define default values for those new extra fields, then that would mean that you can upcast the event to the new version, and that makes it a version. Whereas if you need to do anything more to the event than that, that would make it difficult or even impossible to upcast in the same way, then you should rather consider creating a new event. But yeah, like I said, this is in itself a somewhat complicated topic, and I recommend having a look at this book if you're interested. In general terms, of course, again, the structure of the event store, that is basically the main item that you might sometimes have to deal with when you're updating your application. All right, then what if it's not your code that changes, right? There's a lot of text on this slide here, for which I apologize, a lot of bullets, but yeah, I'm going to talk you through. So technically, everything that's on this slide, or that I mean here, are reasons that are purely technical, right? So they are not based on any functional requirements. So for example, if you use some sort of a framework library for your event sourcing application purposes, oh, I apologize, I bumped the microphone, then there could be a completely new version of this library available. Now, of course, it is somewhat important to know what this update entails, right? For example, the update of the framework you use. What does that actually mean? It is possible that nothing more is required than simply to restart your services after you have presumably rebuilt or redeployed them, or whatever is necessary for your runtime environment, and then you restart them, because if you're lucky, the changes to an underlying framework do not actually influence at all the storage structures and things like that that you're dealing with. Of course, it is very important to be sure of this, right? So unfortunately, I know that this is something that people always like to skip when you use some sort of a third-party tool or framework, and you get a new version of it that has suddenly become available, and of course it's supposed to be much greater than the previous one and whatever, and then they just want to go ahead and use it and benefit from it. And the thought that you might actually want to read the release notes very carefully is sometimes problematic, and yet there is practically nothing much more important than that. So I'm afraid this is important. Well, at this point, it can make sense to create a new deployment, and this is a general or somewhat more general topic really that I could have potentially mentioned earlier as well. Of course, it should be possible to create a new deployment, which basically means, using some sort of an infrastructure as a service approach or something along these lines to create a parallel system. That's the idea. I've got a couple of slides to illustrate this in a moment as well. The idea is that your new system, your new deployment, can run side by side with the existing system for a little while. Of course, you can view this as a step that you initially take as a developer, perhaps, to actually test the changes you make in an update and so on. Can be tested and recreated as necessary, right? Eventually switched and possibly even rolled back if your event store is a shared one. Now, as I just said, we could have used this in other cases. So I'd like to show you here on the next slide what that can look like. I mean, just to illustrate, basically, right? So we have our old deployment over here consisting of a number of read models, and it also uses this event store, right? That's the idea. Now, when we create a new deployment that is over on this side, we use the same event store in the shared event store pattern that I'm showing you here. We use that same event store to populate the new read models. Now, of course, this implies that there are no significant changes at this point to the event store itself, right? So if your update that has become necessary for some reason actually requires you to make changes to the event store, then this is not an option, right? Then in that case, because you would then have to update everything at the same time. However, if you know that at least the storage structures of the event store remain the same, then you can use the shared event store approach. And eventually, the idea is that a client would initially use this connection right here to work with the old read models, and it can then later be configured at any point in time that you like, really, to start working with the new system and querying from here. And of course, it would still execute its commands in the direction of this event store up there, because that has not changed. The great thing about this is that you can change back to the old deployment if that turns out to be necessary for some reason, or you actually never switch to the new deployment in the first place, right? Or you recreate this bit here more than once as a test or development scenario before you decide that this is all good, it's good to go, and now we can finally actually make this switch down here, right? So that's the idea with the shared event store. Very powerful. And in reality, because the technology that you use on the event store basis up here is typically quite stable, I mean, hopefully as well, it can actually be applied quite frequently, this particular patterns, because it's comparatively rare that you find yourself having to change the event store as well. In any case, that is on the new, on this slide here, where we have a new event store, in which case, of course, we populate that new event store up here from the old event store. We populate the read models from there. Now, again, of course, this is something that you can do as a test run ahead of time. And then, technically, of course, you would have to switch this client to start working with the new system. You would have to deactivate this event store here. So you will have some right side timeout here, basically, right? There's not really a way around that in this particular scenario. So for that reason, I think it makes sense to go ahead and basically test your new deployment independently without making this step here, right? So we're not making the new deployment available initially to a client. We basically just create it for ourselves. We test it in depth. And then when we find that that has all gone perfectly well, then we can still throw the whole thing away again and start the actual migration process for the real update, right? So these can be separate processes. So this is basically one of the biggest update flows that you might have to consider, basically recreating your entire system. The downtime in this case is comparatively quite large. You can, of course, consider, depending on your situation, that this old system here might remain available for querying while you run. And there is also a possibility that you could leave the old command side, the right side, available during the new deployment run, which is possible if you use some sort of an incremental update or incremental import process. So the idea would be that any events that are generated over here would also be passed on to the new deployment. Of course, if the new deployment is still in the process of creating its first version of the event store and all that stuff, then it might not be ready to receive those events just yet, right? So you would have to sort that out and make sure that they can be processed later. It's possible to do this. I'm only explaining that this is out of the whole lot, the most complicated scenario of them all. That is a good idea to avoid if you can, right? So there you go. And that brings me to the last of my topics, which is something where this whole incremental import thing comes in again. And this is the job of getting from some legacy application, I mean, as in legacy, meaning non-event sourcing application, to an event sourcing based application. In this case, your job number one is, and this is a complicated one, to derive events from your existing data, right? If we don't have any events yet, then of course we need to create them. Let's say we have some kind of an enormous database full of information that has been gathered by some old system. Then the question is, how do we get this into our new event-sourced system? One idea that comes up frequently is to have a special category of events, initialization events, right? That only serve the purpose of pushing the data into the new system in the beginning. I personally don't like that idea. I mean, it can be useful in some cases, it can be a necessity in some cases, but generally speaking, I would rather like to generate normal events, as it says down here. In other words, the ones that my system would ordinarily support anyway. And I would rather like to figure out ways how to generate these kinds of normal events from the legacy data. Now, in reality, this is not always easy, and there are several challenges. I'm outlining one of the more important ones down here, which is the question of sequences, right? So if you're confronted with a large database full of information and you don't know where it came from, then of course you don't know the order in which it has been created. So you might have to make it up, right? We have timestamps in an event-sourced system on the basis of incoming events, right? And most legacy systems will not have the same number of timestamps. I mean, if they did, then it would be easier to actually recreate the information. Sometimes you might have additional sources like audit logs, for example, that can help you determine the order in which things have happened. Sometimes data analysis mechanisms might help. So, for example, if you have, let's say there's a blog system. I think somebody today talked about an event-sourced blog system, right? So if you have a legacy blog system and there's a user object, but the user object has no creation timestamp, then of course you might be able to find out which was the earliest post that user ever posted, and then you can assign a timestamp for the user creation as, earliest post timestamp minus a couple of days or something. That should be logically fine, right? So that's the point. Data analysis might be necessary to come up with an approach to generate events on that basis. Now, it can be a good idea to basically create these events in some sort of a table on the side of the legacy application so that you can run through the process more than once, right? Feeding those events into your new system is, of course, the main job that you have now. Import the events into the system. And it can be useful to try to do this more than once. It can even be useful to do this during development time, right? You can basically build up your event sourcing system on that basis from these events. You can do that over and over again to get a solid starting point and figure out how everything works. You can do this as an evolutionary approach during development time. So that's all possible on this basis. Pay attention to limits. You might find in real systems that your volumes are enormous if you actually process all those generated events at the same time, right? Be aware of data volumes, data transfer volumes, the timeouts of things, and so on. But you will probably find that out yourself during testing. Everything else that's in here is technically optional because you could begin to run your system on that basis alone. However, it is a good idea to be running the system in parallel, perhaps even during development time, like I already said. And then I also recommend thinking about incremental import. So in other words, your old system could remain in command of the whole process for a while. You can generate events from database triggers going forward, or at least for a while, right? And you could then import those events into your new system. As I'm saying here, it can be useful to have a special event import type of endpoint in your system, perhaps to deal with practical volumes during the big import operation, or you can use commands. that's basically up to you. There are pros and cons for both, but it's a bit hard to distinguish. So I suppose an import is a useful thing to have if you need it anyway for the import of large amounts of legacy data, and then that can be a more straightforward approach. Don't accept commands into your new system until you're ready to actually run from there, right? They would then collide. I mean, assuming that you're running in parallel with your old system using incremental import, then you would run into collision scenarios if you suddenly begin to accept events generated by your legacy system and commands coming into your new system at the same time. That does not seem to be a great idea. There are probably some ways of coordinating both, but then of course you would also want to have ways of flowing the data back into the legacy system, and that just, I can't quite imagine what practical scenario that would really be good for. I would try to work around that in any case. Right, and that sort of concludes everything I wanted to tell you here. So I've got some links here for this presentation if you'd like to have a look at it. And apart from that, I will now pass back to Thomas for any questions, perhaps.